Okay, so we're now going to look at building up a multi-cylinders engine, and the way we're going to do this is we shouldn't need the anchor parts within each sub-assembly, so I'm just going to delete that out, and then we can do a file save, make sure this is saved, and then a file make assembly from assembly. So this is a new assembly. We're going to bring the piston assembly final in as a sub-assembly, put that in its native place first just by hitting the green tick, and then let's bring another one in. Okay, and I also here want to insert the anchor point as well, because we're still not going to use a cylinder. Okay, now what you'll notice is the first part that we bring in has got this F, which means that sub-assembly is fixed in space. We've then got another piston assembly final which has a little minus sign there. That isn't fixed, that's float by default. The reason it's got the minus sign is that it's not defined yet. We can still move it wherever. And we've got the anchor point as well, which is also coming to be fixed. So I can right click on this to start with and float it. So the only thing that is fixed in space is the anchor point. I can then mate up this sub-assembly to the anchor. I can then do a cylindrical mate there to there as before. And then I can bring these in line as well, so there to there. Okay, and then a cylindrical mate between there and there. Okay. Right, now, if I accept that, we'll just have a look at what we've got here. If you note, that moves as one solid lump. It's no longer moving up and down, it's not flexible. Now the reason for that is that when you bring a sub-assembly into another assembly within Solidworks, it makes the sub-assembly rigid. So everything is fixed as in its last save. So what we have to do is make these flexible. So what we do is we right click, go into the properties and do solve as flexible. And if I do that with both, you see the difference in symbols there. I've made that one flexible, that one's still solid. So I right click on the solid one, properties, solve as flexible, and they're now able to move as they should. Okay, so let's have a look now what different mating options we might have here. So if we want to make this one go vertically up and down, we'll do that in a similar way to before. So we start the make command. Let's open up, and now we see our sub-assemblies and our anchor point. So if we use let's have a look what planes we've got here. We've got one going vertically up and down the middle there, so that would be a good point to choose. And then if we choose the piston head again of this first piston assembly, so we go into the assembly, then we find the piston head and go into that part, and again that will have its planes in there. The corresponding plane is that one. Make them so they're always concentric. As we turn that now, see that always goes up and down. We could do the same with that piston head to the anchor, or this piston head plane that we've just picked, that one, we can find the corresponding one. So I'm just going to uncollapse that first one, go to the second piston head assembly, find the second piston head, and then find the plane going up and down in there. So they will now go up and down together. Okay, so they're still independent of each other, but they both move vertically up and down. Okay, right, now let's mate that plane to that one. So they're now flush in line. Just see what happens when we reverse that. We get that into its opposite direction now. Now what we might find there is parallel is perhaps a better option. Let's try reversing that. Okay, let's just try this now and see what happens when we move them. So these are now going around together, but the pistons are at exactly 180 degrees out of sync.